Okay, ladies and gents, so what I'm going to go through today is a lecture that discusses the two deeper strata that are contained within your skin that are below the epidermis or deep to the epidermis. So we're going to focus on the dermal layer and the hypodermis today, and we're also going to address repair. So since we know all of the layers that are contained within the skin after this lecture, we'll talk about what happens when your skin gets injured and what your skin does in order to repair itself. Okay? So I forgot my camera, so I have pictures of our notes, so I'm going to go through them. So again, follow along like we usually do. I'll be scrolling through as we talk about each of the different parts of skin today. Okay, so we're going to start with dermis and hypodermis. So again, we're going to address one of our strata of skin. So again, we have our epidermis, that is our most superficial layer of our skin, and below that, we're going to have our dermal layer. Okay, so right below our dermis, our epidermis is our dermis. And the main purpose of the dermis is to essentially provide support for that epidermal layer of our skin. It's made up of mostly connective tissue, right? Because we've got our epithelial layer that's at the top, and then below that we are going to have our connective tissue layer that's going to be there for support. So inside of your epidermis, dermis, you're going to have two major components that build those strata. So that builds the strata that is your dermis. And so these two layers, they're kind of blended. You can make a distinction between them in your image. You can actually see the papillary layer and the reticular layer in certain sections of the skin if it's stained right and you have a good cut. But it actually kind of blends together as one continuous tissue. But they are distinct layers that are found within the skin. So the papillary layer, we've already talked about this when we addressed epidermis, right? We saw that there was that wavy fold that was present in that layer right below our stratum basale. Okay, and so that is called the papillary layer. So this is named because it contains those dermal papillae. Dermal papillae are just layers of loose connective tissue. So as we've learned with loose connective tissue, right, there's a lot of different cell types and fibers that can be found in it. So your dermis is made up of mostly collagen, but you also have elastic and reticular fibers that are present within your skin. So those things are going to be available to your skin so you can use it to help provide support. So our skin is actually pretty elastic, right? You can take it and pull on it and it springs back, assuming that you're not, old. But if I take my skin right and let go of it, it'll spring back. Okay, so I can pull on it and it'll go back to where it was. So being the papillary layer, as we mentioned with epidermis, it is there to help increase the surface area. Because your epidermis is an avascular tissue, again, because it's epithelium does not have vasculature, but connective tissue does. This layer is actually providing a lot of the nutrients that are necessary for your epidermis to be able to carry out its functions. So for your stratum dermatitivum to divide, or stratum basale to divide, all right, and then those layers to build things like keratin and melanin in order for your cells to carry out those functions. So besides that, your papillary layer is also a layer that's going to have a lot of nerve endings in it. So remember, nerves, their function is to relay sensory signals to the central nervous system, to the brain, so that your brain can then send responses back. So again, it's functioning as the control center. So your dermal papillary layer, the papillary layer, is going to contain many different aspects of this in order for your skin to function. So again, since it's second closest to being exposed to the external environment, it's that second step in carrying signal on. Below your papillary layer, you're going to have what is called the reticular layer. So reticular just refers to, again, a type of connective tissue. In this case, your reticular layer is made up of not loose connective tissue, but actually dense, irregular connective tissue. And so we didn't specify or look at specifically dense, irregular connective tissue, but as the name implies, it's kind of a mess. It's a lot of different fibers that are going in a bunch of different directions that forming this kind of dense network of collagen and elastic fibers that are there to again provide a spring supportive area, but it is a connective tissue proper. That means it's going to have fibroblasts, it's going to have fibrocytes, and those things are going to work together to help protect your body. So like macrophages and mast cells that are there to carry out other purposes. So again, you're going to go, if you're breaking down the strata, right, you've got your reticular layer that is deep to your papillary layer. So if you're asked to identify that, for example, on a slide or a diagram, right, where you're seeing those folds, that's the papillary layer. Where it's mostly flat below that, that's reticular layer. So with the dermis, your dermis is also where you are going to have many of your accessory organs. So hair follicles are going to be found in the dermis, and a lot of your glandular tissue is going to be found in there. So like sebaceous glands and sweat glands and oil glands, those things are all going to be found in your dermal layer. And so being the dermis and being the thing that supplies a lot of the energy to your epidermis, it's going to have a dense network of blood vessels. So it's going to have lots of capillaries, veins, and arteries that are going to carry some supply of materials that are necessary to carry out many of the functions your epidermis needs in order to do its job. But you also have a very dense network of blood vessels. Besides blood vessels, you have a very dense network of nerves and lymph vessels that carry out other functions. Remember, nerves carry signals, and lymph vessels are there to pick up and transmit interstitial fluid as well as anything that leaks from your circulatory system. So it's kind of that backup. So your dermis, that's why, for example, if you get a cut, right, you can take your hand and you can like scrape the top of your skin and you can like scratch it, right, and you're not going to draw blood. But it's not until you apply a lot of pressure and break that layer that you start seeing that, like your skin gets red and you can possibly bleed because it's not going to have an injury and you're not going to feel anything unless the dermal layer ends up getting damaged. And we'll talk about more with repair. Okay. So again, we go epidermis, most superficial, dermis below that is your second layer. Okay, so below your epidermis and below your dermis, you actually have a layer of tissue that is sitting right on top of anything below it. So for example, skin that's sitting on top of muscle tissue. And this layer is known as the hypodermis. You also might see books that call it the subcutaneous layer. So sub means below, like a subway is below ground. So subcuticle, right, cutis refers to skin. So this is below the skin. So this is one of those layers where the distinction is a little iffy, right? Some people treat it like skin because it does directly affect and is directly related to your dermis and epidermis, but it's not technically integument, but it does provide necessary stabilization for a lot of your other tissues to latch onto it. So again, this is the deepest layer of skin, all right, of your integument, and it connects to the underlying tissues. A lot of your hypodermal tissue is actually like a byproduct and it's connective tissue that's surrounding other things like muscle and tendons and ligaments, but your hypodermis does serve a purpose for your skin because it provides that necessary stabilization and that scaffolding in which your dermis uses to help build its structure. So structurally, your hypodermis, one of its main job is just to, again, function as a loose connective tissue. So like with all of our loose connective tissues, it's there to help provide some immune response. It's there to produce fibers that are necessary for structures. But the big thing that you're going to find in your hypodermis is that you're going to find a lot of adipose tissue. So a lot of adipocytes and a lot of adipose tissue. So adipocytes, remember, those are the cells that store fat. So an adipocyte is a cell that stores fat. Because your adipocytes are found in the hypodermis, this is our fat layer in our bodies, right? This is where we are storing that chemical energy that's necessary for times when things are lean, when you don't have as much or as much material available for you in nature to, maintain a weight and maintain body temperature. So your hypodermal tissue here is extremely important when it comes to maintaining just normal homeostatic function in your body. So without this adipose layer in your skin, you can have issues with maintaining your body heat, right? So this is like the idea that really skinny people have an issue, they get cold pretty easily. It's because they're missing insulation, right? You need that insulation and you carry that insulation in areas that are vital. So that's why as adults, we generally carry quite a bit of excess fat in our gut regions, right? Because we have a lot of vital organs that are there, but also this fat being stored there. It's there for a lot of reasons. One of them might be evolutionary, one of them might be to attract a mate. Another reason is because of physiological stability, right? Having this insulation layer across your vital organs, like one, it's there to insulate for temperature, but it's also there to insulate in case like, when a tiger comes and tries to slash your stomach, right? If you got a lot of fat there, it's a lot harder for him to get to your liver and enjoy that. He's got to cut through all that fat first. But again, most of your body fat is stored in this layer. So for men, for example, men and women do carry weight differently, right? They store their adipose or those fat globules in different parts of the body. So like females generally store it in breast tissue as well as thighs and hips. Men's generally store it in facial stuff, and they also store it in chest and gut and butt. That's kind of like the main areas that guys generally store fat. So because we have this differences in fat, structuring in our bodies, right? That's one thing that designates males and females physiologically, is that they have different areas that they store weight. It doesn't mean that an individual can't store fat in random places or all over the body. That's totally true, right? Once you reach a certain point, all areas of your body are going to start storing excess fat. But those are the places that we get to store, that get stored first. Um, it's a little bit different too as you age, right? As you age, you end up storing fat in various different places. Again, those are all linked to things that happen during puberty and changes in your body's physiology. But as your body grows and as an individual starts to age, they start storing fat in different places. And it's harder to get rid of that fat sometimes. So, like for me, as I'm getting older, I'm getting fatter. And it's just because more sedentary and also just getting older, right? That's something that's harder to deal with as you get older. All right. So the other thing with your hypodermis is that even though it's not like skin, it still functions as skin. It still carries out similar has still similar structural components of skin. All right. But the big thing here is that your hypodermis is a layer of tissue that is really lacking any vital organ, right? There's nothing in it that is necessary for survival, right? It's just a layer of loose connective tissue that holds your skin to the tissues below it. It's not very rich in capillaries. It's not very rich in anything beyond just interstitial fluid. So it's actually a really great layer if you want to administer medications and you don't want it to hit the bloodstream too quickly. So like if you've gone to have a shot anytime and you have a hypodermic needle, so hypodermic needles go to the hypodermis. So hypodermic needles are actually releasing this below the skin in an area where there's not very much blood flow so that your system can absorb that medication or absorb that vaccine slowly so your body doesn't get overwhelmed very quickly by it hitting the bloodstream. So again, that all depends on the type of shot that you're going to get. So if you get like a shot in the shoulder, right, they're doing it very deep below the dermis. So that's just the broad view of dermis and hypodermis, right? Just know that your dermis is made up of two distinct layers, the papillary layer and the reticular layer. And you need to know that your hypodermis is below your dermis, and that is the deepest before we get to other body systems, before we get to like our muscular system, for example. Okay? So if you have questions about that, write those down and let me know. And I can answer those a little bit later. So I'm going to go ahead and switch to our next page. So the notes that we did today over dermis and hypodermis, I wrote those on page 27. We're going to now talk about what happens to your skin as we are trying to repair it if it is damaged. Okay. So skin repair in itself, I wrote this on page 26. So skin repair itself is actually extremely complicated process. There's a ton of steps that are occurring as your cells are trying to respond to this damage and the exposure to the outside environment. So skin repair is something that does happen in all of those layers, in your hypodermis, your dermis, and your epidermis. It has to be done in all three because if any one of those layers is exposed to the outside environment for too long, like or your dermis is, for example, your dermis is exposed too long, right? You're exposing the rest of the body to pathogens, debris, and other things that could cause damage or sickness and eventually death in an individual. So again, thanks to skin's containment of a lot of different types of stem cells, so not only just those that are in like our stratum germinativum or stratum basale in our epidermis, but also the fact that we have fibrocytes and we have stem cells that are in our dense and loose connective tissues, those help speed up the rate of healing. So skin itself can heal pretty quickly, or at least try to protect itself pretty quickly in case there is a severe type of wound. Okay, so again, rates of healing in an individual is going to depend on so many different factors, right? It depends on the size of the wound, right? So if you get like a paper cut, that heals itself pretty fast, but if you get like a third-degree burn over your arm, that's not going to heal very quickly. It's going to take a long time. So like abrasions or scrapes take a lot longer to heal than say like a single cut will, okay? And it's just again because of the size of the wound and the type of the wound. So again, and the other thing about skin repair, right, it depends on age, right? Your skin doesn't repair itself as well as you get older. So like if you're a baby and get injured, for some reason your skin is real good at repairing itself, so you're not going to have a scar, right? But if you say get injured later in life, like when you're a teenager, I still have scars I can still see on my body from a bike accident I had in 4th grade. So you can still see that stuff, even though it was like 20, 30 years ago, a long time ago. So You got to keep that in mind, right? So there are differences between individuals, differences due to age, differences due to the type of wound. But all wounds go through the same 4 steps, whether it's a cut, whether it's a burn, an abrasion, all 4 of these steps will occur in your skin in order to repair it. So the first step that we are going to have in our response for skin is an inflammatory response. So you guys have an image that I'll show you later that's on your sheet, the square that's got 4 different black and white images of the skin being cut. We're going to look at that a little bit later, and that's something you need to fill in as part of your homework. Okay. So step 1 is the inflammatory response. So what this is essentially your skin, once it gets cut, your skin is going to respond by bringing lots of blood into that area. So inflammation is going to trigger a swelling of that tissue. So your tissue is going to get larger. You're going to have more blood and more interstitial fluid between your different cells. So by changing that, what happens is the environment in which your cell is in is going to be altered. So fluid is going to start entering the cells get bigger because they are going to be hypotonic to the area around it. So by having less material inside of it, right, water is going to go in, cells are going to swell, and your cells are going to end up butting up next to each other. So this inflammatory response isn't a negative thing. It's a thing to essentially limit the space between the cells. So if you get a cut, that inflammation is going to cause that cells to start getting closer and closer together. So it's kind of wedging them closer so we can start building our network to repair them. Okay. So this is actually triggered by a cell, which is known as a mast cell. So mast cells, if you recall, are one of the specialized cells that are found in connective tissue proper. So mast cells do send this signal out to the rest of your body to tell that this individual area is injured, it needs material in order to repair it. The other thing that you're going to see a lot of that are going to start forming in this area are white blood cells. So phagocytes, which are ones that take material, take them in, and break them up into smaller pieces, are going to be present. And you're going to have macrophages that are there to, again, take up and absorb any foreign material that might be trying to get into that cut. So any cut on your skin is going to immediately expose you to a bunch of viruses and a bunch of bacteria that could cause infection later. Okay. The other thing that starts happening in this inflammatory response is that your epidermal layers are going to actually start moving. So your stratum basale is going to start dividing laterally to try to fill in that space. So you've got a cut here, right? If we say like have this cut, right? And your cells are going to start trying to move around the bottom of this cut so that your tissue can actually repair itself. Okay, so your cells get inflamed, so they get closer together and they smush the cut and make it smaller. Okay. All right, once you have this formation of this inflamed area, the next thing that's going to happen is, since you have a cut, blood is going to start filling into that cut. And what happens is the tissues that are being exposed to the air and blood that's being exposed to the air, a special particle inside of your blood is going to start to react. So thrombocytes are specialized cells, so the other term we learned for these are platelets. And essentially what they are going to do is interact with other cells that are found in blood, so whether it's white blood cells, some other thrombocytes, or tissues that might be in that loose connective tissue layer, dense connective tissue layer that's in the dermis, right? Those interactions are going to form a protein mesh, right? A network that's going to start trapping material in that. So that protein mesh is going to function as a means to kind of trap any bacteria that might be trying to get in, but also start drawing fibers together so our wound will eventually start closing. So again, inflammation, and then those sites are going to fill up that empty space so we have a block. So a blood clot, as the name implies, is something that is just going to cover up that area, right? It's going to stop stuff from getting in and then also prevent stuff from leaking out, so like you bleeding to death. The proteins that are being made when your thrombocytes work together, they're forming this network that's called fibrin. So a fibrin network is a protein matrix that holds the clot together. So these are the proteins that are found there. And they're pretty dense. They're insoluble, so that means they don't dissolve in water, and they can actually, again, serve as a good stopgap in case there's an injury. This is why if you have a scab, you shouldn't pick at it. You should leave it alone, because that scab is there to protect that area of your skin. It helps protect stuff from getting in, and eventually it'll slough off and go away, as we'll see as we go through our next steps. Again, these cuts response are only going to be happening if you do cut into the dermal layer of the skin. If you cut the epidermis, like your stratum corneum, nothing's going to happen. If you dive in deeper and get all the way down to the stratum spinosum or granulosum, then your cells are going to start dividing so that you can fill in that area. But you're not going to have this kind of clotting response until you actually sever any capillaries or veins or arteries that are found in your deeper layers of your dermis. Okay, so again, you're not going to have anything happening until you get to the dermal layer. So because the dermal layer is an area of connective tissue, you're going to have lots of fibrocytes and fibroblasts that are going to be buried in that area. So these tissues, fibroblasts and fibrocytes, repair the basement membrane and the dermis. Okay, and essentially what they're going to do is start building that network so we can have a scaffolding to fill in more cells. So we can build more fibrocytes, more collagen fibers, more reticular fibers, more elastic fibers to start pulling that cut closer and closer together to fill it. The other thing that's happening here is, again, your epidermis is continuing to migrate. So again, you've got your cut, and your epidermis is trying to get underneath that cut so it can then start pushing that clot up and out. Okay, so these will continue to migrate. So it'll try to go below the cut, and it'll start moving it. So that takes a couple days. It takes a couple days for that to happen. So after a few days have passed, then we're going to start healing our wound. So our wound is going to start replacing a lot of different tissues in itself so that it can function normally. Okay. So step 3 is the dissolution of your blood clot. So as your stratum germinativum goes underneath, right, you're going to start connecting those tissues together, and then that stratum is going to start pushing the injury up. So essentially starting to replace those damaged cells from the bottom to the top. So this clot is called, what we say is called granulation tissue. Granulation tissue is just a mixture of the blood clot, the fibroblasts, and the blood vessels that are present to repair this wound. Okay, and these form from the basement layers or basal layers of your epidermis as well as your dermis. And so as those things start to divide, that granulation tissue starts to take over for the blood clot. And the blood clot starts getting pushed away. So as it reaches the top, right, your scab starts to slough off, right? The blood clot goes with it. Okay, and you're just left with fibers, epidermis tissue, and dermal tissue. Okay? So as that clot dissolves, eventually we're going to reach step 4, which is our full recovery. And so this full recovery takes several weeks for the clot to be removed. It can take up to 4 to 6 weeks for even just a simple cut to heal itself completely. Right? And again, that takes time depending upon who you are and how old you are. So it takes several weeks for the clot to be removed, and then once that clot's removed, the epidermis is essentially complete. So you've reestablished that epidermal layer, right, that's got all of the individual strata within it. There's no cuts, no damage, no breaks between the cells. So everything is fused back together and it creates a continuous sheet. So the issue with this and what happens with your body is that as you start working on this particular area, right, as you start building up the scar tissue that's in there, that scar tissue isn't necessarily going to be flush with the top of your skin. So your fibroblasts will continue to produce tissue below where your injury was in that scar tissue, make lots of extra collagen that's going to build up so it ends up being even. So some of you guys might have had a scar or have scars where it feels kind of dipped in, and that's because those scars were pretty deep to begin with, right? It took a lot of tissue for them to recover. So by the time the epidermis covered those areas up, right, the deeper layers didn't end up actually filling in yet, okay, or they may never fill in. But if your fibroblasts are functioning in that tissue, they'll start to go in, fill in gaps with different tissue and end up flushing that. Sometimes, though, you can also have a raised scar. So you guys might have heard of a keloid before. A keloid is a raised scar area. So if you get an injury on certain parts of the body, you're more likely to get these keloids. So like if you have an injury on your back, right, oftentimes back injuries will form these keloids for some reason, which again are just raised areas where there's extra scar tissue stacked on top of everything. So it's not that it's like bad, and it's not like it's gonna lead to something dangerous like cancer. It's just where you have an excess layer or excess of hypodermis and dermis tissue that's present there, and it doesn't serve anything. It doesn't end anything poorly, right? It functions normally. It's just a raised scar. So just know that a keloid is an example of a raised scar. Okay. All right, so The other thing you guys have is this image. Okay, so I gave you a copy of this. It's in black and white, obviously. So what I would like you to do with this is on the page that you have for this information, so the stuff that's on your hypodermis and dermis, on that page, you can go ahead and just glue the edge of that image over your notes that are on the steps here. Right, so glue it on the edge, and then that way you have something you can fold over. But I want you to just kind of summarize and write in the steps that are occurring in this blood clot process. So what's happening in step 1, step 2, step 3, and step 4. Okay. So that's it for the notes on hypodermis, dermis and hypodermis, and how skin repairs itself. So I want you to go back and make sure that you understand those things. If you do have specific questions, feel free to ask, and I'll be more than happy to answer those when we get back together in class. Okay. So tomorrow you guys will have a lecture video that's talking about accessory organs in the skin. So look for that tomorrow. So what you guys can do for the rest of the period is I want you guys to be working on your coloring sheets. You have 2 pages of those, so make sure you read the text that comes with it and then follow the directions as you color this, right? It's just going over the different layers of skin, so make sure that you're reviewing that as you start studying. Okay, so good luck.